Hello guys, I'm Apurva Khernar and I'm back with my second technical task as a data science and business analytics intern at the Sparks Foundation. So for this task, I had to develop an unsupervised ML model to predict the optimal number of clusters for the iris dataset. So first I imported the libraries and modules that were required, and similar to my previous task I used pandas and numpy for array operations, matplotlib and seaborn for graphical visualization, and lastly scikit-learn for ML operations on the dataset. In the next step, I loaded the data into a data frame, and in this data frame the y value, or the value which we are supposed to predict, the dependent value, is fed into the species column, the iris.target. And here in this column, 0 stands for iris setosa species, 1 for versicolor, and 2 for virginica. Here you can see the first 10 rows of the data frame. Then to understand the data, I tried to visualize it using swarm plot. So in this plot you can see how the sepal length, sepal width, petal length and petal width vary from species to species, how they are different from each other. And then I defined the features and labels for this data, that is x and y, and to calculate the optimal number of clusters, here I have used elbow method. So actually there are many methods out there for calculating this optimal number of clusters, like elbow method which I have used, the average silhouette method, the Davis-Bolden score, and many more. The one which I have used is one of the most common ones, and in this one the within cluster sum of squares, that is WCSS, is calculated for a given range of number of clusters. So here you can see that I have initialized the variable WCSS as an empty list, and then in the for loop I am appending the k-means inertia into this list, and then I am plotting this as a function of number of clusters. So here you can see that I have put number of clusters equal to I. So I am calculating WCSS for each number. So as you can see that this is an elbow shape, that is why it is called elbow method. And usually in this method the optimal number of clusters is the number at which the bend occurs. So here in this one I took 3 as the optimal number, because here after 3 there is not much drastic change in the data, that it is gradually decreasing. Before 3 it is suddenly falling down to some value, and also the bend occurs at 3. So that is why I have used 3, and I use this value for developing the k-means model, and I predicted the data. So here you can see that the data, that is, the predictions are not very accurate. In fact they are not at all accurate, because here the first at least 10 of them are 000, that is setosa, but it is predicted as being versicolor, which is not right. And that is why clustering is not usually implemented in this data set. This data set is usually used for classification operations, but still in this task I tried clustering, and this is the result that I got. So you can see these are the 3 clusters, and the yellow circle or the yellow dot is the centroid of these clusters, each of them. And this is how I developed the clusters and calculated the optimal number of clusters. And that's it for today. Let me know how I can improve this model in the comment section, and hope you like this video. Thank you.